All right, we're back. Taking a look at a couple more review problems, this time around using some technology to help us out. So rather than just straight up whiteboard work. So I pulled up Desmos here because, kind of unsurprisingly, somebody wanted to take a look at the linear programming problem, number 13 in the review packet, talking about the book bag company with their messenger bags and their backpacks. So I've gone ahead and got a Desmos window pulled up here to help us identify corners of our feasible region or solution region, however you'd like to describe it. You'll notice I've already kind of got the window set up a bit. This runs from 0 up to 400 in the x direction, and then 0 to 400 in the y direction as well. If you needed to play around with this, that's fine. It's just clicking on the wrench up in the corner kind of pops that stuff up so you can see the values in question. I technically scaled the x and y axes so I can get at the corners, but not this is hopefully that part you're kind of used to. All right, so now let's go ahead. We've got to do the legwork of setting up our constraint inequalities before we try to figure out what to do with our to find a solution for our book bag company's problem. So I'm going to let X stand in for the number of messenger bags we make, let Y stand in for our number of backpacks produced. Okay, so the constraints we have to work under, beyond the obvious we want X and Y to be non-negative, are labor hours and the amount of fabric that's available. So we have 750 labor hours available over the next week, and based on the problem that we're given here, each messenger bag, which is our X variable, takes 3 labor hours, so that would be 3X, plus, let's see, 2 labor hours for backpack, so 2Y, and then we want that to be less than or equal to 750. So now we've got that guy nicely sketched out right there in this red color. All right. So coming to the fabric available, we've got 1,200 square yards of fabric. Each messenger bag takes 3 yards, so that's a 3X again. Then each backpack requires 5 square yards worth of fabric, so we'll have plus 5Y. And we want that to be less than or equal to 1,200. So now you can see we've got our feasible region sketched out right here. Again, technically, remember the coordinate axes are cutting this off. It's just cleaner in Desmos not to put them in as actual constraints. So as you hopefully will recall, we have to find a max and min at corners of this region, which is the overlap here, this area that's kind of both pinky and blue at this point. So our corners making our way around, we've got 0 to 40. Technically, we also have 0, 0 down here at the bottom. We've got this intersection, which is 150 and 150, and I'm going to change line so I can get that last x-intercept there, which you can see as 250, 0. All right, so those are our 4 corners. Both our minimum and our maximum are going to have to occur at one of these corners because this is what we call a closed bounded region. We could put a circle around this thing that's shaded both colors. All right, so now I'm going to pull up my Buddy TI-83 to handle the next bit here. You'll notice I've already taken the liberty of typing in the objective function. The profit is $15 per messenger bag, $21 per backpack. So 15 times X plus 21 times Y. So we'll investigate what happens at each of our corners. I'll go ahead and change these X and Y values to zeros. Not that this is terribly surprising, but if you make none of anything, hey, you make no profit. That's probably not much of a surprise. All right, making our way around our other corners. So we had 15 times 250 down here at that intercept right there, plus, and I'm being a little pedantic here, 21 times 0, because that's, the Y value there is 0. We get 3,750 bucks at that guy. All right, making our way back around. This one was 150, 150, so we have 15 times 150 plus 21 times 150, and that's 5,400, which is more than either of the two that have come up yet. All right, the last intercept was 0, 240. It's blocked by where I've got the calculator, but so anyway, so 15 times 0 plus 21 times 240, and we get 5,000 $40 dollars in profit for the week. So it looks like of our 4 candidates here, the 5,400 is the largest of the bunch. So that's our maximum possible profit. And it occurs when we make 150 backpacks and 150 messenger bags. So there's the solution to that guy. All right. So another problem that somebody wanted us to take a look at, again, kind of relies on the calculator, at least the way I do it. I think it matches up with the way WebAssign expects you to do it as well. So jumping to problem 17, where we've got some data about number of years and number of stores a retailer happens to have available. All right, so as a reminder, to enter our data values, what we're going to do first, we come down to this guy, we hit stat. Then we hit edit, and it's got a bunch of stuff in there. Let me, I'm going to clear these guys out. So, all right. So now I'm going to enter into L1 my year counts. So that's 0, 1, 2, 3, 4, and 5. And over here, clear these guys out. I'm just hitting the delete key. Hopefully you can see the little clicky thing there. So we have 3. We have 6, we have 13, 24, 48, and 65. And note our numbers match up, nicely. All right. Now, we've got our data entered. To get that exponential model, once I've got the data values entered, I'm just like triple checking to make sure I haven't, skipped over anything. Awesome. All right. So now, hit that stat key again. You're going to go over to the calc menu and scroll down through the list. The guy we want is exponential regression. So for the purposes of Math 210, you don't need to worry about any of the others. This is the one we're using, expreg. All right. So we do expreg. Now, it's automatically pulling from L1 and L2. If you have a TI-84, it might prompt you for some more information. You shouldn't have to change much. The big thing I want to do is store this formula that it's going to give me so I can use it in part B of the problem. So to do that, I need to go into this variables key right here, go over to yvars, just hit function. I just want to stash the equation away in y1 in my y editor so I can look at it. Okay? Okay. So it does some thinky. So our formula matches up with this a times b to the x. So here's our a value, here's our b value. The review packet asks us to approximate this accurate to 4 decimal places. So that would be 3.2935, and then we'd have 1.8873 raised to the x as the equation. And if you go into our y editor, oh look, it's actually storing way more accuracy than we need, but that's fine. All right, so now, for the next part of the problem, it asks how many number of stores is this formula going to predict 10 years down the line? Okay, so for what it's worth, I'm going to take a look at the graph of this guy and then use a command we've used a bit previously to track down the answer. So for what it's worth, here's my graph window. So, it's sitting right there. Feel free to copy it over if you'd like. Pause the video. I get it. Anyway, so when we do our graph, it starts out really, really low, which it probably should since we started out with only 3 stores. Okay, now, what I'm going to do to figure out the value after 10 years, that corresponds to an x value of 10, right? So what I'm going to do, second, go into the calc menu, and I'm going to use this very first command here labeled value. We used it a time or two before when we were doing linear programming to track down y-intercepts. This time around, I'm going to enter the x value I'm interested in plugging into this thing. You could technically just plug 10 into the formula manually, but I've got it right here. So, all right, so I'm going to plug in x equals 10, see what happens. All right, so from looking at what we get right here, what we're after is this y value, and we'd want to round to the nearest integer. Our company probably doesn't have, 35% of a store open somewhere. So we have 1,888 stores open further on down the line. Okay, so that's the problem involving exponential modeling using your calculator. You can technically get away with doing the same sort of thing in Excel. The format looks different, but some of you did that on the test and it worked out okay. I would warn you, be careful. Google Sheets is, I saw from the project, when it does this exponential regression, it's there, but the formula is quite different, and so WebAssign will probably not be happy with a formula you generate from Google Sheets, based on what I saw in the project. If you don't have access, to a physical calculator or to Microsoft Excel, there's a couple of apps I might recommend to you. If you happen to have an Apple device, if you look up Calculate 84, like one word, in the App Store, that's a pretty good facsimile of a TI graphing calculator. For those of you with an Android device, the wabbitemu software, i.e. the thing that is sitting on the screen in front of you right now, is available through the Google Play Store, so you could go get that if you prefer. Texas Instruments may also have an app, but I'm pretty sure that one wouldn't be free because it's Texas Instruments. So that's a couple more review problems. I've got to go back to the board for a couple more, and then we'll call it a review session. So keep on watching.